Solving quadratic equations with complex solutions. Now that you've learned about complex numbers and different methods to solve quadratic equations, let's consider solving a quadratic equation with complex solutions. Let's get started. Given the quadratic equation ax squared plus bx plus c equals 0, where a does not equal 0, and where a, b, and c are real coefficients, the complex solutions are negative b plus or minus the square root of b squared minus 4ac over 2a. If the discriminant here, b squared minus 4ac, is greater or equal to 0, the solutions are real numbers. If the discriminant, b squared minus 4ac, is less than 0, the solutions are complex numbers. When the discriminant is negative, the quadratic formula gives the following complex solutions. Negative b over 2a plus or minus the square root of 4ac minus b squared over 2ai. So we have a real component and an imaginary component. Solve. 5x squared minus 2x plus 3. So let's plug in all these a, b, and c values into the quadratic equation. So we have x equals negative b plus or minus the square root of b squared minus 4 times 5 times 3 over 2 times 5. So that's 2 plus or minus the square root of 4 minus 60, which is going to give us negative 56 over 10. So our discriminant here is negative 56. So let's continue this on the next slide. On the previous slide, we got up to this point here. So the next step would be removing this negative sign from under the radical and adding an I out front. So then we can break this up into the real and imaginary components. 2 over 10 plus or minus I times the square root of 56 over 10. We can actually break this 56 up into 4 times 14. The square root of 4 is 2, so we can bring that out front, giving us an answer, the solutions of 0.2 plus or minus 0.2 times the square root of 14 times I. Solve. X equals 2x squared plus 7. First step is to move this into standard form, which we've done here. The a, b, and c values are here. Let's plug them in. So x equals negative b, which is 1, plus or minus the square root of 1 minus 4 times 2 times 7 over 2 times 2. So this equals 1 plus or minus the square root of negative 55 over 4. We can break this up by, first we're going to say 1 over 4 plus or minus the square root of 55, the square root of 55 times I, because we want to get that negative sign out, divided by 4. And you can see our solutions are here, which is also 0.25 plus or minus 0.25 times the square root of 55i. The discriminant d equals b squared minus 4ac is the quantity that indicates the nature of the solutions of a quadratic equation given ax squared plus bx plus c equals 0, where a, b, and c are real coefficients. The table below summarizes the possible outcomes. If the discriminant is less than 0, there are two complex solutions. If the discriminant is equal to 0, there's one real solution. If the discriminant is greater than 0 and it's a perfect square, there are two rational solutions. And if the discriminant is greater than 0 but it's not a perfect square, there are two irrational solutions.